In this video we're going to have a little look at pyramids and cones, and we're going to work out the volumes of pyramids and cones, and we're going to look at the surface areas of cones as well. Okay, so volume of a pyramid sounds complicated, but it's actually dead easy. Okay, simply this: the volume of a pyramid is given to you by multiplying 1/3 by the base of your pyramid and multiplying that by its height. Okay, so let's have a look at a quick example here. So here I've got a pyramid. Now it doesn't matter if it's if the top of your pyramid is wherever. It could be in the middle, it could be over here, it could be over here. It doesn't matter. Okay, so you can have some really wacky pyramids. Here I've got a triangular based pyramid, and the volume for this is simply, so the volume is simply 1/3 multiplied by the base area. So here it's 6 multiplied by the height of my pyramid. Okay, so my volume is going to be 1/3 of 24, so that's 8 centimeters cubed. Okay, some questions you might, if you've got a question like this, this is a rectangle, this is a right angle triangle, isn't it? So you might be given some of these dimensions, like the base and the height of this triangle, and you could work out the area of it, and then you could multiply it by the height, and then you could find 1/3 of it. Okay, so you can work out the volume of pyramids that way. And actually, a cone is almost like a special type of pyramid, because again, we're doing the same thing. We're doing 1/3 of the base area multiplied by the height. It's just that here we've got another expression for the base area for a circle. It's pi r squared. So for example, here I've got a cone. Okay, this is the base, and this length here is the height of my it's sort of like a pyramid, isn't it? But it's the height of this cone. So if I want to know the volume, it's going to be 1/3 multiplied by pi r squared, so pi times 3 squared, multiplied by the perpendicular height here, which is 4. Okay, and I can type this in my calculator. 1/3 multiplied by pi multiplied by 3 squared multiplied by 4. That gives me 12 pi, or 37.7 centimeters cubed, and here I've rounded that to 1 decimal place. Okay, finally onto surface area. Now this is the one that's slightly more confusing. In fact, if you can work out where this all comes from. It's a bit of a handful, so I'm not going to go through it now. But you need to know an extra thing. You need to know this length here. We call this here the sort of the slant length. Okay, so this is the slant length, and this would be your height as before, but we don't really need that now. Okay, so the surface area of a cone is pi times r times the slant length, and then you add on to that the area of the circle on the bottom here. Okay, so this is actually the curve. This here, pi r l, that gives you the curved area of your cone. Okay, and then here we've just added on the circle on the bottom. Okay, so let's have a go at some examples. So for this one here, for the same cone, I've got a slant length. So my surface area is going to be equal to, let's make sure we're using the formula properly. So it says pi times r times l. So pi times the radius, 3, times the slant length, which was 5. Okay, that's going to give me the curved surface, and then I need to add on to that pi r squared, so plus pi times 3 squared. Okay, pop this in my calculator, let's see what we get. So pi times 3 times 5 plus pi times 3 squared, that gives me 24 pi, or 75.4 centimeters squared. Remember, it's an area. if I round that to 1 decimal place. Okay? So just be careful on those ones. Always go back to the formula if you're not sure. Okay? L is your slant length, not to be confused with H, which is your perpendicular height of your cone.
Joash Maths.